Hello everyone, thank you for the things. In this video, we would like to present our project about 3D reconstruction of plane using close-range photogrammetry with leaf type variation. This project was prepared by our team. The members are Dias Habib Dananta, Wilda Monika Mukti, and Diah Nurahmi, and guided by our supervisor, namely Professor Lilik Sutiarso and Dr. Andri Primanugroho. Did you know we can measure plane without damaging them, only use camera? Three-dimensional reconstruction is not only used to measure the height, weight, and volume of the planes, but also useful to visualize plane objects in a virtually three-dimensional form. This research uses CRP method or close-range photogrammetry method. The close-range photogrammetry method uses the basic principle of overlapping measurements between photos using different angles of view and camera orientation measurements. The three-dimensional model obtained is very determined by the number of slab areas between photos. At previous study, the 3D reconstruction using close-range photogrammetry method have been used for volume measurement of dummy plane as object. The objective of this study is to present the application of 3D reconstruction of planes using close-range photogrammetry method for leaf type variation. In this study, we use Chinese cabbage, lettuce, and tachoy.
In this slide, I will explain the schematic diagram for the process of 3D reconstruction of plane using close-range photogrammetry. We will take the photo of the plane using DSLR camera. Then we process the photo using 3D FEV Pro for the 3D reconstruction. After the photo being processed, we will get the estimated volumetry and we can proceed to the evaluation. And we can compare estimated volume and manual volume. Before we take a picture, it's necessary to calibrate the camera. Calibration is intended to know the deviation of error that occur. A calibration has been performed in the RMS error value of 0.103. So it can be stated if the camera is good for photogrammetry because the result of calibration not more than 1. This video shows the process of how we edit object with 3D FEV. First, we select the part to be removed until we get an object that we want. The stage is repeated again and again until the same object is obtained with the result of manual volume measurement. The result of 3D reconstruction for plane object with leaf type variation can be used to estimate the volume and its shape in virtual. This first video shows the result of 3D reconstruction for Chinese cabbage, and the second for the lettuce, and the third for the tachoy. This table shows the comparison volume between estimated and actual volume for each commodity. Because 3D FEV has its own criteria in volume measurement, calibration is required. So, based on the comparison above, can be known calibration factor. Based on the known relation between the estimated volume and the actual volume for Chinese cabbage has R square 0.9077, for lettuce 0.8728, and for tachoi 0.8634.
This is the comparison volume between before and after calibration. In this slide, there are several pictures. The first pic is Chinese cabbage, the second is lettuce, and the last one is tachoi. You can see two candles. There are blue and orange. The blue candle is showing manual volume, and orange is showing estimated volume. Before calibrate, the comparison between actual volume and estimation is too far, but after calibrating, not too far. However, validation is still needed. This is validation result. The plan with the lowest error as indicated by mean absolute percentage error was lettuce with 18.61% of error, followed by tachoi, which was 12.04, and Chinese cabbage 2.15. Root mean square error on cabbage showed the error, that is 27.65, lettuce 14.12, and the last one, tachoi 2.22. The accuracy of the close-range photogrammetry method tends to be low for lettuce and tachoi, because the original leaf with abstract and overlapping shape made the full reconstruction of some part of the plant was not presented in accurate value due to complexity and unseen part. Based on our research, we have the conclusion. The first is three-dimensional modeling has been carried out based on the close-range photogrammetry method as an alternative to non-destructive observation and measurement. Photo captured before processing the image into 3D model. The 3D model obtained using 3D FCP software still present good visual while still retaining the characteristic of plant. The second, system validation is done by testing three methods, namely linear regression, root mean square error, and mean absolute percentage error. Based on the monitoring system performance test that has been conducted, it was obtaining that Chinese cabbage has the best value of accuracy. The result of the smallest mean absolute percentage error value on Chinese cabbage plant was 2.15%, followed by tachoi plants 12.04%, and lettuce 18.61%. Furthermore, the root mean square error value in Chinese cabbage, lettuce, and pagoda 27.65, 14.12, and 2.22. After finish the study, we would like to say thanks to Agricultural and Biosystem Engineering Universitas Gadjah Mada and Smart Agriculture Group Research and Rekognisi Tugas Akhir Direktorat Penelitian Universitas Gadjah Mada. So, this is the end of our presentation. If there are any questions or feedback, please don't hesitate to leave your comment in the section. Thank you.